topic before us, and that is resolution of forces. We'll continue from where we stopped earlier as well. You're welcome once again, and this is Jake the Font A teacher, and we're looking at resolution of forces. I want to deal a bit deeper on resolution of forces. So we have two forces here, P and Q. At a point, the magnitude of P is 4 Newton, and the magnitude of Q is 3 Newton. If P acts in the direction of 30 degrees northeast and Q acts in the direction of 60 degrees southeast, find the components of P and Q, and find also the resultant force R of P and Q. Let's take our diagram. The horizontal axis, which is X, then the Y axis, which is the vertical axis. We'll take our Q here from this angle, 60 degrees, to the vertical axis, which is 60 degrees, and we're taking P 30 degrees to the vertical axis as well. Then we're taking a broken line to cover it up to produce a right angle triangle at the upper and the lower axis, or lower quadrant, upper quadrant and lower quadrant. So we want to use SOHCAHTOA to resolve this problem and resolve these forces P and Q. Where we have sin theta, we want to opposite over hypotenuse, and we have sin theta as well, px all over p, which is from here, p, this is px, that's our opposite, all over p, that's our hypotenuse. So we'll take care to be our px, that is the p along the x-axis. That's what this ps implies. So cos theta is adjacent over hypotenuse. In this regard, this becomes our qx, and this becomes our q, and we'll have this side facing the what? The opposite angle. So I have p y all over what? P, and this is a py adjacent to this angle. So as we proceed, we'll go further to resolve. Let's extract the first quadrant, the upper quadrant, and that is the positive x and y axis, from here down to this point, then down to this point. That's what we want to extract now. And when we extract that, we'll keep it by the side. Then we'll resolve gently and gradually so that you can follow on and grab the concept of resolution of forces. It's not difficult. So here we have extraction of positive and extraction of positive x and y axis. We resolve along the horizontal axis, that is the x-axis. So we are working with sin theta, which has become sin 30 degrees, opposite of hypotenuse, which we have here, px all over p. That implies that px, if we cross multiply, it becomes p goes to this side, that is p sin 30 degrees, which gives us ps equal to 4 times 0.5, and that gives us 2.0 Newton, and that is the force along the x-axis. So we resolve also along the vertical axis, and that is the what? The y axis. For us to do that, of course, you can recall that this is our stuff. So you have your y axis, close a bracket. Then we'll pick this one, and this is P along the y axis. And here is it. Py cos 30 degrees equal to Py over P. That is adjacent over hypotenuse. And that gives us what? Cos 30 degree. So Py equals to P cos 30 degree. That is Py is equal to 4. Mind our P is 4. 4 times 0.866, and that gives us 3.46 Newton. We have succeeded in extracting our positive x and y axis. So let me extract a quadrant and see exactly what we did. This is the quadrant, the upper quadrant. This is the y axis and the x axis. And this is our P. And this is our 30 degree. And this is our broken line. So we extracted this out to this point. And this is actually where we did what we did for this positive x and y axis. Because look at, this is y axis, this is x axis, this is y axis, this is s axis. So for extracting the positive x and y axis, this is positive y axis, this is positive x axis. So we just extracted it, break it out of the diagram here and illustrate it here. And from here we applied all this one. So from here to here is our px, that's the force along the s axis. Then here is our py, force along the y axis. Of course, since this is a broken line, it's parallel to this, so it's still the same thing with what? This. So this line here is just like an object of this line here. This is an image of this object. So it plays the same role as our px, that is the p along the s axis, and this is p along the y axis. And that's why I'm having px here for this side and py here for this other side. So we extract our diagram again as we proceed further to the second part of our question. This is our angle, 60 degree. Then what we normally use, SOHCAHTOA, once again, so that we can trace the question. So half sin theta equal to p x over p, and y cos theta is equal to py over p. So we want to extract the negative y axis and positive x axis. This is the negative y axis, is pointing downwards, but this is a positive x axis from our diagram. So have our 60 here, then this x, the image of this line will be reflected in this place from here to here as a broken line. So we resolve along the horizontal axis, which is sin theta, using this sin theta of qs all over q. Whenever it's horizontal axis, it has to be x axis. So we resolve the force along the x axis. So qs over q, that implies that qs is equal to q sin theta. That gives us what? That qx equals what? 3, because 3 is our sin theta, times 0.866, and that gives us what? 2.5 Newton, or 2.59 Newton, which is 2.6 approximately. So we'll quickly resolve along the vertical axis, and that vertical axis is the y axis, but this vertical axis is downward axis. So all the same, it's a vertical axis, but it's a vertical line. We go ahead to extract this, so that if we resolve along the vertical axis, we'll have minus y axis. So cos theta will take care of that. So cos 60 degree equals what? Qy all over Q. That implies that our Qy will be equal to what? Q cos 60 degree. That is, our QS becomes 3 times 0.5, which is our 60 degree. We replace it with 0.5, and that gives us 1.5 Newton. So let's summarize our solution. We have dealt extensively with them individually and patiently, slowly, so that we extract it. So we're picking out our summation. Summation of Px, that is the forces along the x-axis. We have Px plus Qs, which is P sine theta plus Q sine theta. These are Q sine theta here. On the other side, we have P sine theta on the previous slide. So 4 sine theta plus 3 sine 60 degree. And that is what we have here. And this. Alright. This is for our horizontal axis. So our broken line is up here already, giving us a right angle triangle there. So here we'll simply solve this. Replace sine theta, sine 30 degree with 0.5. That gives us this. Sine 60 with 0.866. And summation of our P subscript S will give us 5.09. When we add up these two, multiply and add up, it gives us 5.09. So summation along the y-axis, that's what P subscript Y will be equal to what? Py plus our Qy, and that will be equal to what? P cos theta plus Q cos theta. So here we're having 4 cos 30 degree plus minus 3 cos 60 degree. Of course, you know, understand why this is minus, because if you look at here, this is a negative axis, so that's why we're having minus. And if we multiply, we have our EP subscript Y will give us what? The result of this one, subtract from this one, will give us 1.96 Newton. So let me draw a little, give a little illustration of what we have done so far. And the reason why we have minus here because this is along the y-axis, but it's a negative what? Y-axis. So that's why we're having minus here. So if we resolve this Q along the y-axis, we'll have minus. So actually here there ought to be minus in this place. So our summation of P subscript S and summation of P subscript Y, and that is the resolution of force along what? Along the S axis, the summation, and the summation of the resolution of force along the Y axis. We are still on it. We're not yet done. We want to get the angle between the angle the resultant force is taking. And here we're having our quadrant again. Our imaginary line, which is the image of X, image of Y, giving us a right angle triangle here. So I know whenever we talk about right angle triangle, there's some solution that works with right angle triangle. Either a sine, cosine, and tan rule works with it, or if we are to look for the side, we can also use Pythagoras theorem or Pythagoras rule. So as we stand here, we have resolved our forces, and we have one for the force along the y-axis, and we have it as summation p subscript y. Then we have for x as is summation p subscript x. Then we have our resultant, which is r. Then we have our theta, which is this. So in order to solve this opposite, this adjacent, since we already have theta here, so we will quickly use Pythagoras rule to get our resultant first of all, before we work out the direction of the resultant, which is theta. So using Pythagoras theorem, we have r squared equals the bracket of summation px p subscript what x squared plus summation p subscript y squared, close the bracket, square it. Then taking the square root of this p subscript x, close the bracket, square, plus summation p subscript y, close the bracket, squared. So we'll have this, close up the square root, we'll have this as well. So we have substituted this is for this, and this is for this. On squaring them, we'll have r equal to what? 2.25.91 plus 3.84. So we'll take our square root, we'll add them up first. We'll have 25. We'll add it up, we'll have 29.75. We'll take our square root, we'll have 5.45 Newton. And that gives us our resultant. That's the magnitude of our resultant. So times theta, we want to look for the theta now, giving us the direction of the resultant force. And tan theta is opposite over adjacent, which is simply what? Equivalent to tan theta equal to summation of p subscript y all over p subscript x. And that is what we have here. P subscript x. Okay. We'll proceed further to substitute. We have 5.09 divided by 1.96. First, tan theta equal to 2.60, where theta is equal to tan inverse of what? 2.60. And tan inverse of 2.60 will definitely give us an angle in degree. And that is, finally, we have theta equal to what? 68.96 degree, which is approximately 69 degree. So that is the direction of our resultant force, which is this, and the magnitude is what? 5.45 Newton. So we have finally done the resolution of the question before us, and this is the final answer. And this method of resolution works for all kinds of method of resolution involving right angle triangle. Once we break it up, let's use SOHCAHTOA to resolve the forces. Always understand that irrespective y is here and the resultant goes this way, there's still a vertical line here, which is just a mirror image of this particular one. So we can take it down here and still call it y-axis, because it's just a mirror image. It's a vertical line and this is a vertical line. They are similar. Alright, so that is just what you need to grab about resolution of force, and it's as simple as that. As you try more questions, you become more familiar with it and it becomes more simple. So I urge you to check out some questions and try your hands on them.